All right, guys, today we're going to be reviewing one-step equations. If you hear some weird noises, that's because I have a chihuahua on my lap and he's chomping on a bone. So I'm just going to dive right in. When we solve equations, our goal is always to, you'll hear this a lot as you go along in math, isolate the variable. So the word isolate means to be alone, right? So we're trying to get that variable to be alone. That's the whole point of solving equations. And to do that, we move the other numbers in the equation away from the variable. That's how we isolate it, to move the other numbers away from it. And we do that by doing the opposite operation to both sides of the equation. And I probably don't have to tell you what opposite operations are, but just so we have them written down, we know the opposite of adding is subtracting, the opposite of subtracting is adding, the opposite of multiplying is dividing, and you guessed it, the opposite of dividing is multiplying. So let's just try some examples here. Example number 1, the first thing we're going to do is locate that variable. Remember, a variable is a number that represents a number. Our job is to isolate that variable by doing the opposite operation to both sides of the equation. So I'm going to say to you, find the variable and ask yourself, what is happening to that variable on the same side with the variable? So right now, 8 is being added to x. We don't care about the 12 because the 12 is already on the other side of the equal sign. It's not bothering the x at all. The only thing by the x is the 8. The only thing on the same side of the equal sign as the variable is the 8. So since 8 is being added to x, the opposite would be to subtract 8. So we're going to bring this x down. Oh good, the cat is coming out. So now the dogs will probably go crazy and chase the cat, and you can all enjoy that during my video. 8 subtract 8, of course, is 0. So they kind of cancel each other out. We don't have to write x plus 0. We don't ever have to write adding 0 to something. So we just have an x on the left. And then remember, our golden rule of equations is whatever you do to the left side, you have to do to the right side. So since we subtracted an x from the left, we have to subtract an x from the right. 12 subtract 8 is, of course, 4. So when I say that we're doing it to both sides of the equation, you can think of the equal sign as like the middle of the equation. And if we're going to subtract 8 from the left of the equal sign, that side, then you also have to subtract 8 from the other side of the equal sign to make it balanced. Okay, so hopefully as we go through, we won't have to talk as much as I did on number 1. That was just kind of to get us started. So I'm going to ask you, where's the variable? It's right here. What's happening to it? We're subtracting 4 from it. The opposite of subtracting 4 would be to add 4. We'll bring down the x. And remember, when we did integers, we talked about how the sign in front of the integer belongs with it. So a negative 4 plus a positive 4 is 0. So again, we have just x all by itself, and then 10 plus 4 is 14, and that's our answer. I forgot to mention something very important, and that is when you solve equations, you can check them. It's the most beautiful thing. You can always tell if you get an equation problem right, because you can take your answer for the variable and replace the variable in the original problem with your answer, and if it's true, that means you got it right. So let's try it for this one. I can take 4 and replace x in the original problem with 4, and guess what? 4 plus 8 equals 12. So I checked it and it was right. Over here I can replace the x with 14 and copy the rest of the problem down. 14 minus 4 is 10, so I got it right. So always check, especially on a test, right? I mean, why not? Okay, so over here we're going to find the variable. Here it is. Ask ourselves what's happening to the variable. We're adding -6. Well, I could subtract negative 6. That would be the opposite of adding negative 6, to subtract negative 6. What does subtracting negative 6 look like? It's really just adding 6 anytime you have the double negative, right? So let's add 6 to both sides. Negative 6 plus positive 6 is 0. That's the whole point, right? Is to get the thing that's on the same side as the variable out of there, so the variable is alone. And then 17 plus 6, of course, is 23. I can check, is negative 6 plus 23 equal to 17? It is indeed, so I got it right. Next one, here's my variable. Ask myself what's happening to it. I am subtracting 15. The opposite is adding 15. We'll do that to both sides. Negative 6 plus 15 is 9. Negative 15 plus 15 is 0. You can write it this way or that way. It doesn't matter. Most people will write the variable on the left. Let's try a fraction one. Same exact approach, looking for the variable, asking ourselves what's happening to it. We're adding 3/4, so let's subtract 3/4 from both sides. Over here, these cancel, and I just get x. So my answer is going to be whatever the answer to this fraction problem is. So let's get some common denominators here. Negative 3/4 would be like negative 6/8. So that's negative 7/8, and that's my answer. And you could check it. Make sure it's right. All right, so everything we've done so far was undoing, like doing the opposite of adding and subtracting. Over here, these examples are with multiplying and dividing, so let's see how that works. Here's my variable. Ask yourself what's happening to the variable. Right now, x is being multiplied by negative 2. The opposite of multiplying is dividing, so I'm going to divide negative 2 on both sides. What is negative 2 divided by negative 2? It's 1, right? Anything divided by itself is 1. That's why we did it, because we're trying to get x by itself. 8 divided by negative 2 is, of course, negative 4. And then we don't have to write a 1 in front of the variable. We're just going to write x equals negative 4. And we can check it. How do we check it? We take the x and we replace it with our answer. So we'll do negative 2 times negative 4 equals 8. So 8 does equal 8, right? We got it right. We checked it. We're sure. That was Lily choking on I don't know what. All right, so next problem. Here's my variable. Ask yourself what's happening to the variable. The variable is being divided by 3. I'm actually just going to write this one down here. I just want more room. So since x is being divided by 3, I'm going to do the opposite operation and multiply by 3 on both sides of the equation. So over here on the left, if we're doing some cross-canceling, these 3's cancel out, and I just have x over 1. I know that x over 1 is just 1. Anything divided by 1 is just itself. So I'm just going to write x. And 2 times, or negative 12, I don't know why I didn't see the beginning of that. Negative 12 times 3 is negative 36. You can check it. Negative 36 divided by 3 is actually, there goes the Apple Pencil, negative 12. Oh goodness. Where did the Apple Pencil go? Oh no. You guys know that I don't start videos over, so now I have to get up, move the dog, and search for the Apple Pencil. That fell off my lap. Okay, I got it. Okay, next question, number 3. Find the variable. I don't know if anybody watches my videos. They must laugh at me if they do. Okay. X is being multiplied by 5, so I'm going to divide both sides by 5. That's the opposite of multiplying. And so the 5's cancel, right? 5 divided by 5 is just 1. You can leave your answer like this. If you really want to, you can say like negative 3 4/5, but you don't have to. Those are the same thing. I actually like this one better. All right, another example here. Look at this one. Negative x over 11 equals 22. We've talked so much about how you can put that negative in the numerator, in the denominator, or even with the fraction bar. Let's put it in the denominator for this one. So since x is being divided by negative 11, Let's multiply both sides by negative 11. That's the opposite of dividing, right? So these cancel, and I just have x equals whatever 22 times 11 is. I'm actually just going to do it in my calculator to speed things up. 242. And it's negative 242, right? Because we have a positive times a negative. And then there's one last example here. Thanks for hanging in there. Negative x equals 20. If there's not a number in front of the variable, it actually is a 1. Negative 1x. Since x is being multiplied by negative 1, we're going to divide both sides by negative 1. These cancel. Negative 20 divided by negative 1 is negative 20. Now, you might not need to do that much of a detailed explanation for that because this is just saying the opposite of x is 20. So what's x? Negative 20, because the opposite of negative 20 is positive 20. So we get the same answer that way. All right, I'll do another video for these examples right here that are also on the notes, but thanks for watching.